So hello and a very warm welcome here to the Parker booth at Bauma 2025. Parker Hannifin is proud to be the global leader in motion and control technologies. Here at Bauma, the motto is technology inside that moves your world. And so we are really looking to fulfill your wildest engineering dreams and to partner with OEMs in mobile machinery and off-road applications. What that means is that we want to together find the answers to greater efficiency, improved safety and intelligence in your off-road applications, and all that while reducing emissions. No small task. So up next, we'll be diving into electrification technologies for your combustion machines. And we'll be talking about sealing technologies, electric drives, motors, pumps, and much more. I'm delighted to be joined by our global experts, so I'll come over here and introduce them. First up, it's my pleasure to introduce Parker's Electric Motion and Pneumatic Division head. He is in charge of product management and business development there. He has over 20 years of experience in the electrification of off- and on-road vehicles. Herzlich willkommen, Frank Durban.
Hello.
Our second speaker is a huge fan of Bauma, which he has visited many times during his 36 years in the hydraulics industry. At Parker's Hydraulic Pump and Motor Division, he helps customers discover innovations in their systems to upgrade their mobile applications. Bienvenue, Blaise Goupy.
Thank you.
And to complete our trio, he is a newbie at Bauma and excited to apply his vast experience in the automotive industry now to the off-road sector. At Parker, he is a global expert for clean tech in the engineering materials group, where he is focused on sealing solutions for everything you can imagine. A very warm welcome to Dr. Stefan Reichle.
Yep. Thank you. Welcome.
So let's dive straight in. Let's say that I am a design engineer for off-road applications and I want to electrify my combustion engine. Give me some motivation, gentlemen. I want to know, how do sealing technologies, electric drives, motors and pumps, how do they all work together to enhance the performance, overall system performance? Stefan, starting with you.
It's a very good question. If we are talking about electrification, that means we are talking about the need to electrify the entire propulsion system. That means starting at the battery over any e-drives, motors, hydraulic systems. All of them need to be electrified. So, and all of that components which are included in such an electrified system need a sealing system. And if you are talking about a sealing system, all the people who are doing that single components are not specialists in sealings. We are the specialists for sealings, but we are not a specialist for the components. So that means there is a need for a cooperation between all the experts. The experts for the components itself and the experts for the sealing, as an example. As an example, the most important system or component inside the electrified system is probably the battery, because the battery supply the electric energy to the entire system. However, it will be then charged by the power grid, or if you have any internal combustion engine and a generator who are charging up the battery, or any fuel cell system what is connected to it. The battery is the main part of an electrified system. And if we are talking about sealing a battery, that is a really, really important function, because we have to keep the battery in a safe condition. It should be protected by any external influences. So that means we are talking about water or other fluids which can come from the environment, dust, vibrations, a lot of things what can happen. And also internal medias, like medias which are coming from the thermal management system. All that medias and particles need to be protected against to intrude inside the battery, so that we have there any issues. And if we are here talking about a sealing system, here we have the chance, if we are talking about with the experts and are doing the cooperation, we have the chance to reduce assembly forces. Why is there a need to reduce the assembly forces? If we reduce the assembly forces of the seal, we can reduce the wall thickness of the system, because the system should not be longer so stable as it needed if you have a strong seal. or if you have a seal which is requiring high installation forces. Additionally, there's another option. You can also probably reduce the bolt connections, and so on and so on. There's a lot of possibilities how you can reduce the size and the volume of the battery, which also helps you to reduce the weight of your entire system. What would be great. And then you have a hermetically sealed system. What is great? But then you are fighting against with other problems. If you have a hermetically sealed system, then you have probably some issues if you have any changes in your pressure differences between the housing and the environment, probably which can come by ambient pressure differences, or if you're changing the weather conditions. All that has an effect to the ambient pressures and also to the pressure in relation to the pressure inside the housing. Here you have the need, if you have a hermetically sealed housing, what is great because you have a full protection against the environment, you need a solution how you can equalize the pressure differences, especially if you have a fast pressure increase, which is coming from the battery. Probably in a case of emergency, that means the battery cell starts to burn. Here you need also the option, although you have a hermetically sealed system, to release that pressure on a fast way to the environment. Otherwise, you will face problems like a bursting battery. So for that reason, there's a lot of discipline what you have to consider, which from a perspective of a standard component designer is not really considering from his nature. But with the expertise of the people from the other disciplines, you have always the chance to improve your system, probably by reducing weight, reducing size, improve your system performance at all.
Okay, thank you, Stefan. Blaise, would you like to add anything to that overall system performance? What other factors would you add in?
So, of course, when you drive a pump, I'm going to talk about the pumps. When you drive a pump, the specificity of the electrification is that you're going to go on flow on demand. And that's novel because before you had the speed of the engine that would give you the flow. If you have a variable displacement, you could check it up. But with the electric motor, you can accelerate extremely quickly and you can reach much higher speeds. And these higher speeds allow you to have more flow or identical flow with a smaller pump. And a smaller pump means smaller torque, and smaller torque means a cheaper electric motor. So that means high performance, lightweight, small, and cost effective.
Okay, and Frank, from your point of view, is there anything else you'd like to add?
Yeah, I would like to build on what Blaise just said, the whole topic of creating flow on demand. And obviously, in order to do that, you don't just need the pump, you also need an electric motor. So one important consideration is that you need to have a motor technology that offers all the right connection interfaces so it can seamlessly connect to the pump. Another consideration when you talk about motors is usually weight is always a constraint in mobile machines. So it's very important to have motor technology that offers the right power density. And good motors or world-class motors can offer up to like 4 kilowatts per kilogram power density. So that is an important consideration. And so is efficiency of the motor, because batteries are very costly, expensive, right? So you need to make sure that you get the best out of that battery and achieve the longest range of a vehicle that you can. Good motor technology offers highest efficiency over a wide operating range. But then it's not just the motor. If you want to achieve the best systems efficiency, you also need to take a careful consideration into selecting the right inverter that drives the motor. So the inverter is what converts the DC current from the battery into the AC current that is required to run the motor and make it turn. I always say, like, the motor and the inverter, they need to be well balanced. It's a package. You cannot get the best system efficiency if you don't pay enough attention on both of those components. Think of the inverter and motor as of like a human and a bicycle. So when I'm riding my bicycle, it's perfectly adjusted to my preferences, my size and everything. So I'm at my best. I can achieve my best performance. I can try to ride the 24-inch wheel bike of my daughter, but I won't win the race. I'm not at my best performance. So the same thing happens when you pair the motor and the inverter. You want to make sure that the inverter is scalable, that it can adjust to the right power size of the motor. Otherwise, it's unbalanced. And if you achieve a good balance, you can achieve efficiency of that combined system of up to 97%. And then lastly, what I would also add is take some consideration and pay attention in the traction system of your vehicle as well. Looking at a conventional diesel engine-driven vehicle, for instance, the process of braking is very wasteful. Every time you brake a vehicle, you're basically generating through the kinetic energy that needs to be brought down to zero. You're basically generating a lot of friction and heat losses in your mechanical braking system. To give an example, every time you brake a 20-ton vehicle from 60 kilometers per hour down to zero, that generates about 1 kilowatt hour of wasted braking energy. It's wasted. It's completely lost in the braking system of your vehicle. Now, if you think of an electrified vehicle, you can applying permanent magnet motor technology. You can also use that permanent magnet motor to operate as a generator, which allows you to regenerate that braking energy back into the battery. And as I said, batteries are very costly, expensive. So it's another method how you can extend the range of your vehicle that you should consider. And good permanent magnet motors, they give you the same efficiency when they run in generator mode as when they run in the normal motoring mode.
Okay, thank you for your individual views. I'd like to open up now some questions for the audience. Is there anyone here in design of an electrification system? Any questions you have for our experts on these topics that they've just been talking about? If not, we'll continue with the theme. Any questions from the audience? Anything you'd like to ask right now? We can come to more questions at the end, so do think about anything that you'd like to ask them. We'll have time for that, I hope, at the end. So we've talked about the how. Let's discuss a little bit the why. How do electrification technologies contribute to sustainability and reducing environmental impact, which is also one of the main reasons why we're doing that in construction machinery? Stefan, can you give us some numbers?
I can give not too much detailed numbers. I can just give an example, but that is a little bit more from the passenger cars. Let me say, I have our own electrified passenger car and I'm driving that with that. And as an example to the past, where I need a fuel of 6 or 7 liters of fuel consumption per 100 kilometer, my electric car currently is using just 2 liters of fuel equivalent any longer. That is coming, as already explained by Frank. The e-drives are much more efficient in compared to a standard internal combustion engine, and also all the other systems which are connected to that engine are running with less power consumption in compared to the existing solutions. And so for that reason, if I transfer that to the construction machinery, there is a lot of big potential to reduce the power consumption. And I think for sure Frank has a little bit more numbers available who can give you a better picture.
I was going to ask, can you just transfer it to the construction machinery, or are there specific things that one needs to take into consideration in construction machinery? Can you give us some examples for CO2 reduction, emissions reductions in wheel loaders, excavators?
Yeah. So, I mean, bigger picture-wise, the International Energy Agency suggests that the combined manufacturing and construction sector, they account for 57% of the overall total global emissions. That makes about 20 gigatons of CO2 emissions per year. Now, some other studies show that about 400 megatons of that is directly related to construction machinery. Working with our OEM customers, we gained experience in electrifying many different platforms and vehicles. And one example that I can share is a 2-ton mini excavator in its electrified version is able to save about 3 tons of CO2 emissions per year on a normal duty cycle work cycle. So 3 tons of CO2, that to visualize a bit further, that would require you to plant about 100 trees just to compensate those emissions. And then another example is a 20-ton excavator, which can already save about 15 tons of CO2 emissions per year. Now, you can make the math how much trees that would make, right? But those are some practical examples of how electrification can really help to drive the sustainability goals that we all have.
Okay, Blaise, how about you? Can you give us some examples of successful electrification projects?
Yeah, we have a long experience in the industry. With the industry, flow on demand means that the most efficient system is the system that rotates only when you need it. And so we've seen this in the industrial machines where we have gained between 50 and 60% energy because indeed the pump doesn't rotate just when you need it. So it really depends on the type of machines. But that's the novelty, is that now in a mobile machine, you can have the flow requested just in time and for what you need. And that secures a lot of energy, and energy means CO2 emissions.
Okay, what other factors are beneficial in sustainability, Frank? And I think you had a project in mind with refuse trucks. Can you tell us about that one?
Yeah, sure. So one project that I can personally relate to is refuse trucks. We got quite a lot of experience in electrifying those vehicles with our customers. And you know, the beauty of electric refuse trucks, not only do they help to keep emissions out of the cities, but there is another silent revolution which comes with electrifying refuse trucks. So if you have ever been woken up at 5 a.m. in the morning by a refuse truck driving by your house, like me, then you can probably very much relate to electrification and the benefits that it can bring. I mean, the disturbing noise of the diesel engine revving up when the garbage bin gets lifted, emptied, and compressed inside the vehicle. It's very noisy. Now, the electrified equivalent, because of the flow on demand concept that Blaise mentioned, because of the electrified engine, is significantly less noise emissions. So it becomes very much more environmentally friendly, but also, very, very much less noise. So that's very much appreciated by everyone, by your neighborhood, but also don't forget about the drivers who will, get through the day much less exhausted. It's much less exhausted for them as well, because it's such a convenient environment with all the reduced noise, so they can get home in the evening much more relaxed and much more safe.
Okay, thank you. And Blaise, I think you had an example of a project at a port terminal. Can you tell us about that?
Correct. Terminal tractors. So indeed, we went with the electrification for some function that you don't use often, which is just lifting the container. And for this, we went with the GVM and a pump. And so here it was really flow on demand. It was pushed a bit further down the road because we also used green fluids, biodegradable fluids. And so it's really important because a pump was designed to rotate at 1,000, 1,500 RPM, but the electric motors here can rev up extremely quickly. So we learned that indeed fluids, had a limit in these suction conditions. So here we have a terminal tractor that is not creating any emissions. And if ever there's a problem with the hydraulics, we'll have no problem because you have biodegradable fluids. So that's the trend that we're seeing on next generation of machines.
Okay, well, you just said the key word, next generation. What advancements do you foresee in your respective fields that will further drive the electrification of construction machinery? Stefan, perhaps starting with you.
If we are talking about the future and the advancement which will drive the development, then I think we were talking about the power density that will increase more and more in the future. So that will have also the need, because, that's coming by the more powerful system, but it will also coming by reducing the size of the system. So the packaging size will be smaller and smaller. For what increase the power density of the system, what make the need for better cooling. That means you have to integrate additional thermal management solutions. And here in that case, we are talking about the requirement for additional ceilings, because the most of the thermal management solution will be water cycle solution or any kind of immersion cooling solution or any other cooling media solutions. And all that medias are running through your system, are connecting any cooling plates, and so on and so on. And you have to keep away that medias from your components inside the system to avoid a fire in case of a hydraulic media or to avoid any kind of electrical short circuit, which can also create a fire or a malfunction of your system. So for that, there will be a need for small sealing solutions, for materials which can resist that thermal management medias, and also designs who can work with that small viable place or size, volume what you have available in your assembly room.
Okay, thank you. Frank, any further advancements for electrification? Any particular technologies that you see arising in the future?
I would say, first of all, one thing I would mention, Blaise and I have a long history. We and our teams got together 15 years ago because we had this shared idea that there must be better ways how you can connect hydraulic pumps with electric motors. At that time, everyone was using an external coupling and bell housing to connect the two components. That was extra weight, extra cost. It was difficult to install. But we started that journey at that time to integrate the two products together. Now here we are, fast forward 2025, Bauma, with a fully catalog of what we call configured e-pumps, which is pumps and motors that can be directly connected with a male-female spline connection. It's much more tight, less weight, doesn't need any external components. And I think that is something that will evolve further. So you will see even more tight integration of motors and pumps, both components being more optimized to each other to really enable maximum performance for the electrification of work functions. Another thing I would mention is in general a trend towards more integrated solutions. So customers will be able to choose from whatever level of integration they prefer, whether it's electrification components, subsystems, or complete systems. And then Parker has all the ecosystem available for whatever choice you make to electrify your vehicle in the fastest and best possible and most efficient way.
Okay, you've touched upon it. Blaise, I'll ask you though as well. Why would I partner with Parker in my electrification journey?
So it's a good question. The answer is we've been working on it for 15 years. We started in the industry. So you see here on the right a little example. We started with one shaft that was coupling the electric motor and the pump. It was working very well. It was very dynamic, no backlash. But then industrially, it was a bit more complex. So we decided for the customers to choose the electric motor and the different kinds of pumps to combine it and to have some patent systems to avoid the fret and corrosion. So we have different solutions. So now we have already answered to a problem that should come, like we have had years ago in the PTOs. So that's one evolution. The electric motor, the speed comes for free. All right. So and in the pump, the speed was the limit. So when we talk about the next generations, it is us, the pumps, trying to raise a little bit the bar and going much higher in speeds. And here we're launching at the Bauma this year a little T8 Mini that's 5,000 RPM. And so 5,000 RPM self-priming, it doesn't exist as a pump. So that's the way that we see the future. And we're going to continue this on the different technologies. That's what electrification brings. And if I may, a second innovation we have here that you will see on the side is that we can integrate this in the tank. So on a mobile machine, you don't have space, as you said. You always have oil. And when you dip the system into the oil, not only you cool the electric motor, you have a better suction conditions for the pump, but also you reduce the noise level because with a high pitch, you have a high frequency and it's easier to cut this frequency. So a lot of novelties and some are already available.
Okay, where can I see the T8 Mini that you've just described?
Near the pump area.
Is that under hydraulic?
This is correct.
Mobile hydraulics.
Yes,
okay.
Thank you.
So, and if you had to pick one product to showcase here at the booth, what should people be looking at?
Oh my God, I was not prepared for that question. That is a very difficult one. It's hard to pick one.
You probably have more than one, but if you had to say, you have to come and look at this product for electrification.
I would really encourage everyone to have a look at the new Generation 2 GVI, Global Vehicle Inverter, which, as I mentioned, is a perfect companion product to the GVM motor. But then the GVM motor, as Blaise explained, is a perfect product that integrates seamless with the pumps. So we have some of these configured e-pumps on display over there. So if you have an opportunity, take a look at that. That would be my top 3.
Okay. Thank you. Stefan, do you have one hot product you love to show everyone?
Yes, I would recommend our clip vent valve. That is a battery vent valve who helps to ventilate your battery system and also to keep your battery safe in case of a thermal event of the battery cells.
What's it called again? I missed the name.
Clip vent.
Clip van.
Yeah.
Okay, great. Any questions from the audience? We still have a couple of minutes for our experts. If you'd like to know anything about electrification for your combustion machines, okay, perhaps you need another coffee before you get some more questions. So, gentlemen, will you be all here at the booth for the rest of today?
We will.
Do take a look around the booth, where the booth is divided in 4 themes: clean technology, electrification, digitalization, and mobile hydraulics. And we've got the great shift screen, which is sort of like an X-ray for the wheel loader. So if you'd like to explore Parker products and solutions using that shift screen, that's a great way to find your way around. Is there something you wanted to add, Blaise?
Yes, yes, please. So, as we said, you've seen there's a lot of novelties. You've run around this Bauma. 3 years ago, electrification was everywhere. The business is not picking up. So we don't know too much where all this is going, but we're here to prepare it. So this means that behind the scenes, we have test rigs around the world working on e-pumps day and night to try to better understand what's going on. So that when you want to integrate such a system, we have the experience. So that's our work behind the scenes, but always be ready. So we don't know where it's going, but we have to be ready.
And there are further clean tech solutions with hydrogen, combustion engine and hydrogen fuel cells, which is on the clean tech wall here in case you want to look into that as well. Thank you so much for your time. Blaise, Stefan, Frank, thank you for being part of the talks here at Parker. Thank you for your attention.
Thank you.